Hello, Internet. How is your Sunday going? It looks like some audio issue. I'm not getting audio from the Christmas music clip. Let's see what's up with that. Okay, now I think it's working. But yeah, there wasn't any audio at first, so I'll have to take a peek what's up with that. But anyways, we are on to day 10. And so far, the Commodore has kept up with all the puzzles that we have had. So that has been quite nice and frankly quite unexpected. I was kind of thinking that there would have been some puzzles already that the C64 wouldn't be able to handle, but we'll see. Maybe this is the day when things become computationally really heavy. And oh, it looks like there's a lot of text today. So there's 3 pages of text. Let's take a look at what we have for today's puzzle. So here we go. Pipe maze. You use the hang glider to ride the hot air from Desert Island all the way up to the floating metal island. This island is surprisingly cold and there definitely aren't any thermals to glide on, so you leave your hang glider behind. You wander around for a while, but you don't find any people or animals. However, you do occasionally find signposts labeled Hot Springs, pointing in a seemingly consistent direction. Maybe you can find someone at the hot springs and ask them where the desert machine parts are made. The landscape here is alien, even the flowers and trees are made of metal. As you stop to admire some metal grass, you notice something metallic scurry away in your peripheral vision and jump into a big pipe. Okay. It didn't look like any animal you've ever seen. If you want a better look, you'll need to get ahead of it. Okay, an animal jumping into a metal pipe. Got it. Scanning the area, you discover that the entire field you're standing on is densely packed with pipes. It was hard to tell at first because they're the same metallic silver color as the ground. You make a quick sketch of all the surface pipes you can see. Your puzzle input. Okay, I think we have a map. We have a 2D map puzzle. The pipes are arranged in a 2-dimensional grid of tiles. Oh, now I have this pausing issue again. I didn't fix this the last time. I didn't have time, but this is supposed to be the pipe symbol, but this becomes some kind of weird character. So pipe symbol in ASCII. I bet this was a pipe in ASCII, but I'm doing the PETSCII conversion wrong, so there's this kind of weird symbol. I'm not sure if that shows well to the camera. But yeah. Minus, that's a minus. Minus is connecting, it's a horizontal pipe connecting east and west. Okay. It's a 90, that's an L. Uppercase L is a 90-degree bend connecting north and east. J is a 90-degree bend connecting north and west. 7, south and west. And F. So J, 7, and F. And then, yeah, and then the period is ground. S is the starting position of the animal. There is a pipe on this tile, but your sketch doesn't show what shape the pipe has. Okay, so there's S is starting point, but that has like an unknown pipe configuration in it. Got it? Okay. Based on the acoustics of the animal scurrying, you're confident the pipe that contains the animal is one large continuous loop. All right. For example, here's the square loop of pipe. So there's F minus 7, then vertical pipes, then L minus J. If the animal had entered this loop in the northwest corner, the sketch would instead look like this. Okay, so that's now an S. And well, there's these star symbols that don't quite line up now, but yeah, I get the idea. In the above diagram, the S-tile is still a 90-degree F bend. You can't tell because of how the adjacent pipes connect to it. Unfortunately, there are also many pipes that aren't connected to the loop. This sketch shows the same loop as above. Oh, what is this? Okay, so all the periods have been replaced with random characters, but the original loop in the middle is still there. Hey, good morning. Hey, Akarimon. How is your morning going? In the above diagram, you can still figure out which pipes form the main loop. They're the ones connected to S. Pipes, those pipes connect to pipes, those pipes connect to, and so on. Every pipe in the main loop connects to its two neighbors, including S, which will have exactly two pipes connecting to it, and which is assumed to connect back to those two pipes. Wait, every pipe in the main loop connects to its two neighbors. Okay. Oh, 2 a.m. Okay, you're up late. So wait, you're like West. Oh, you're like West Coast US. Is that right? Something like that. 10 hours behind. So it's midday here at 12 p.m. Okay, so here's a sketch that contains a slightly more complex main loop. SJFJ. Okay. So this one goes like this around this whole thing. Got it? Here's the same example sketch with extra non-main loop pipe tiles also shown. Okay, so why do we have these non-main loop pipe tiles? I think that's gonna play into the second part, if nothing else. Or maybe we have to identify what is the loop. Are you from Finland? Yes, exactly. From Finland in here. If you want to get out ahead of the animal, you should find the tile in the loop that is farthest from the starting position. Find the tile in the loop that is farthest from the starting position. Because the animal is in the pipe, it doesn't make sense to measure this by direct distance. Instead, you need to find the tile that would take the longest number of steps along the loop to reach from the starting point. Regardless of which way around the loop the animal went. In the first example with the square loop. Okay, so the farthest pipe distance from the, you can count the distance. Each tile in the loop is from the starting point like this: 0, 1, 2, 3, and then 4. In this example, the farthest point from the start is 4 steps away. Okay. Here's the more complex loop again. Here are the distances for each tile on that loop. Got it, okay. Find the single giant loop starting at S. How many steps along the loop does it take to get from the starting position to the point farthest from the starting position? Okay, so we're being asked this distance to the starting position. Oh, I like this puzzle. This looks nice. Okay. Yeah, I think we should be able to handle this. And the C64 should be able to handle this, hopefully. Okay, so let's get the so yeah, here it is. So this is one of no wait, what is my example? This is my example. Actually, let me do this, yeah. So this is my example input. Save to floppy disk 2023.in10.txt. No, not input, example 10.txt. Cool. And did I have... Yeah, so this one. 9 2023.example10b.txt. So so there's two examples for us to play with. This complex loop and then the simpler loop. Yeah. Okay, and then the puzzle input. Save to device 9 2023 the input 10.txt. Today people were kind of slow to solve this problem for some reason, maybe just the weekend. Oh, I see. Well, who knows? Who knows? Yeah, I mean, I might be here for an hour or 2 hours or 3. Who knows how long this is gonna take me, but I'm starting to form an idea of what to do here, at least for the part 1. Of course, part 2 is gonna do some weird things with these extra pipes. So that's gonna be a surprising thing. Maybe they'll form a bigger pipe or something like that. But yeah. I guess you already solved this, so you have all the idea of what the story is gonna be like. But yeah, hopefully we'll get there. Yeah, but you're faced with some serious hardware constraints. Yeah, yeah, maybe. I mean, this might be the day when C64 is getting so. But I think this can at least make the first part, which I'm pretty sure should be fairly decent. So let's see if I can browse the puzzle. Okay, so it's too large again. I cannot see this. Okay. Okay, so let's see what we're going here. A real hardware and dot magic. Yeah, hi Smith Mule, how's it going? Yeah, real hardware here. So that's the name of the game for this one. So, okay, the usual mantra: include libc first, and then we start with a function. So, what I'm going to do is let me do a map. 20,000. This should work. And then file f equals f open 2023.example example 10.txt and then read from floppy disk 9. Okay, so this is already becoming the usual thing. Now, previous puzzles I've solved by using either fgets, like fget string, or fscanf, but here I'm now going to use fread. So I'm gonna use fread, and how did it work? Map. And then size. Actually, how many bytes we're going to read? So yeah, 20,000 and well, let me do this size of map and 1 and f. And now I'm seeing that my network connectivity is immediately acting up. So let me save this 2023.10a.cpp. I haven't quite had time to start digging into why this is. Oh, that was the assert. That was the assert that failed. Yeah, so when I get an assert, that throws off my proxy server. So, but now I'll just 2020d.10a.cpp reload the page, so it's gonna work. My real hardware is 90% rust. I got ripped on eBay. Oh no, still trying to get it running. Oh no, you got an item that wasn't quite as advertised, I suppose. Yeah, that's a bummer when that happens. But I mean, give us a nice project to work on, I guess, right? You get to have a great fix-up moment. Okay, so so now I'm curious, how well does this work? Whoa, what just happened? 653. What the heck? Okay. Something isn't quite what I expected. Let me print f. What do I have in my map? A long-term project, yeah. Okay, so the map is right, but this return value, what the heck? I thought this was supposed to be returning me the number of bytes read, but maybe not. Yeah, I'll check that out later, but now what I'm gonna do is do this instead. Or could it be that I screwed up something? Something again. Let's see. Length is 30. Okay, so why am I not getting the line endings? But through. So there's supposed to be a minus L pipe F7. There's the second 7. S. Oh, that's the next line already. Okay. That is kind of weird. Okay, now I'm debugging my C standard library again. So this is a C standard library that I wrote like in 3 days before I started this thing. So these kind of quirks are bound to happen, but for int I equals 0, I is smaller than 10 plus plus I. So I was hoping to get the line endings here. Map I. So now I need to debug a little bit of what do I have actually read in this buffer. 10. I do have the line ending. Oh, it just isn't showing up. Not so standard library. I mean, yeah, I mean it takes such a such a time to fully develop a thing, and yeah, I was dealing with a lot of features that I needed to implement here, but so I'm getting a 10, but oh, is my printf not printing? So if I do -r, this should also be a new line. Yeah. Why isn't it -r? This has a value of 10, right? It's a 13. Oh, so n was was a 10. Okay. So I have -n's here. Okay, but that's perfect. Okay, so everything is fine. Everything is working just like I want, except this size. So I'll figure that out later. So now I get the length of the map. So printf is just not doing line breaks on these ends, and now I need to get the width. Width equals stir of map and this new line character minus the map. And then height equals length plus width minus 1 divided by width. Printf. Actually, I don't need the height. I don't care about the height. Okay, I give up. You can be a char. You can be a char so I can get rid of this stuff. Width. So double check our width comes out right. Width equals 5. Yes. Okay. So now I have the width of the. No. Actually, +1. I basically need a stride, not a width. Yeah. So this is now gonna be the width of the map. Yeah. And I don't care about the height because I don't need to. I mean, I can calculate it if necessary. Okay, so save. And then I need to find out where is the starting position. So let's do that. U16 start equals, so we do the same thing. Stir map and then S minus map. That's gonna give the starting position, and starting X equals start modulo width, and starting Y is start divided by width. Start XY equals let's see how this works. 1 1. Yes, so for the first example we are at 1 1 in the beginning. Cool. All right. And then actually I can put this F close up here immediately so it's nice and compact. So then we are looking for the loop length. Actually, before I go ahead, let me run this on the actual input so that I can figure out like what's the size of the map or the width of the map. Well, I should probably, I don't even know if it's gonna fit in my 20 kilobytes. Yeah, I might be crashing if it doesn't. I should print that as well. Ooh, it's reading a lot. It's reading a lot. During some of the earlier days, the runtime was dominated by reading from file and then. Okay, that's not right. 59576 for the width. Or is that right? Is that supposed to be the width? No, that couldn't be the case. Wait. Do I have a bug in my PETSCII conversion here? That this is like this. Okay, now I get to wait all of that again. This was something like a couple of minutes. Maybe I should look into getting that Jiffy DOS chip into my floppy drive so that they would be somewhat faster to load this stuff. That might be quite helpful. Okay, so now I see what my issue is. So now I get the proper width and the starting coordinates for the input. So I have this bug in my AOC client again that, like, I had this issue before. It looks like I only partially fixed it. So the actual puzzle input has \r line endings and the example inputs have \n line endings. I would wish them all to have this \r, but yeah, my AOC client. I think I botched up the generation of the line endings. So R for input and then N for example. I'll fix this so that in the future I'll have R everywhere. But yeah, let's just work on the example now. Or actually, let me do this. 0. While map W is not N and map W is not R. So now I'm gonna be safe with both of these input forms, because if I need to change between the example and input, I don't want to be plus weight plus weight. Yeah. So now I should be fine with both of those, so that'll work. Okay. Then so what I want to be doing is now walking according to these pipes. Actually, now I need to first find what is the starting. So I am at this position S here. Where's my example? Where's a good example? That's the simplest example. So, well, let's look at this. So I'm in this position S. I don't know if this shows up. And I need to figure out what is which direction does this actually go to. So what's the simplest way? So I'm gonna look at the 4 directions and find a matching. So that's gonna be like if well, if I start writing this, I'll see how to simplify. If map, actually let's do at xy, which is map y times width plus x. Oh, these multiplies are gonna be killing the C64. Absolutely murder. Like this multiplication is not good for the C64's health. But I'll optimize that if I need to. So if at x plus 1 y is like this. So now I need to this is gonna be a little bit awkward. Maybe I'll find a way to simplify. So the compiler is gonna do the compiler is going to optimize. Even though I write this multiple times, it's not gonna compute this multiple times. But it's gonna do oh, plus y. It's gonna do no, not plus plus x. It's gonna do like common sub-expression elimination and merge these together, so I don't have to worry about that. Oh, or oops, where's my or here? Or at x plus 1 y. Actually, this is getting a little bit unwieldy, so let's do 2 types. So So we're gonna do our own common sub-expression elimination here. Or C equals F It might be nice to replace all of these characters by like bit masks that tell which direction the thing is going, but that's maybe premature. Not F, not F. What was it? 7. Actually, that's all there is, right? Yeah. So if the character to our right is one of these 3, that means that the loop is gonna go to the right. And that means that we're gonna walk to the right to start with. Else if let's do this right, up, right, right. Char down equals at x, y plus 1. Char left equals at x minus 1, y. Char up equals at x, y minus 1. Else if down equals, now this is it like this character? Okay, now I actually need to figure out what is that. What is that incorrectly converted character? So so actually now I'm gonna do this. Actually, let me do this. Up. And I have this loop construct here that I was about to build. So I think that should be, yeah, so that's 220. Okay, so that's just botched up. Define down 220. So so that's just a small hack that I'm going to leave. Now I really do need to fix that for my final code, but that's going to be fine for now. Or down equals J, or down equals L. plus y. Else if left equals minus, or left equals L, or left equals F. That's the character, minus x. Else. Well, actually, this cannot happen because we we must find one of those. And actually, this cannot happen either. So I can just do this. Because it's gonna be a loop, so I have to find one direction. So if I don't go right, or if I don't go down, I must be going up and left. So I can just take one of those. And then I'm gonna do u16 steps equals 0. And while starting x equals x and starting y equals y, while x is not starting x or y is not starting y. So I'm just gonna traverse a full loop, or like a full tour around this loop. So now I need to look at where I got to. Oh, and I need to record which direction I walked last, like on the previous step. So here I need enum direction up, down, left, right direction. Plus plus x direction is to the right. We walk right. Plus plus y direction equals down. Minus minus x direction equals left. So this direction thing tells us which direction we walked the last time. So I think now with this info, I should be able to figure out the whole loop. So switch C. Let's see what we have. If it's, well, if it's what did I name it? Down. So it's an up down thing. If direction is up, we're gonna continue going up. So so if the last step we took was up and we come to a vertical pipe, then we came from the down direction of the vertical pipe. So we're gonna continue to go up. So minus minus y. Case else plus plus y. Wow. The white space is is a little bit wonky in this because I just have 40 columns, but creative formatting works well. So, and in here also, like, we're going to continue in the same direction, and this is also the case. This minus thing is also similar. We're going to continue in the same direction. So if direction is to the right, plus plus x, else minus minus x, break. Yeah. So those are the straight parts. Then let's see what would f look like. If direction equals up. So we came from this down direction, we came up. So then we're gonna go right. So we're gonna plus plus x, and direction is now right. Otherwise, we came from the right, so we're gonna go down. So plus plus y, direction is now down. Yeah, I think this should be fairly solid logic. How about L? If direction is down. So we came from the up, so we had a down direction. We're gonna go right. Else, we're gonna go up. And then I think there's how many cases? Are there like 6 cases total? Yeah, there's 4 corner pieces and then 2 straight pieces. So we've covered FL, so we have 7, and then we have J. So those are the remaining ones. Okay. So if direction is right, we came from the left, we're going to the right, so now we're gonna go down. Direction is down. Else, we must have come from bottom, we went up, now we're gonna go left. So minus minus x, direction equals left. Break. And then the last one, let's say our direction is right. We're now gonna go up. Else, we came from the top, so direction is gonna be now to the left. Direction equals left. Whoa! Okay. Default. Okay. So default is that we're gonna kill execution. Undeclared hold. So that's in include C64 kernel.h. This is a header that I wrote that contains just the entry points for the C64 kernel ROM. So that's basically like the BIOS or the operating system of the C64. Yeah. Oops, we got something wrong if this happens. And then after we do that, that's plus plus steps, right? And I think we were asking, like we were asked what was the farthest direction? So of course it's a loop, so the farthest direction is going to be halfway from either way. So I need to divide these final steps by 2. So farthest semicolon steps divided by 2. Oh, not LU, just U. Yeah. So let me see what happens when I run this. Is this while loop gonna run into an infinite loop? Is that gonna happen? Oh, now I know what I'm gonna do actually with this multiplication. This one. I'm going to convert that I don't maintain x and y. I'm just going to maintain the linear position. And when I do minus minus y or plus plus y, that's instead like plus minus plus equals width or minus equals width. But that's an optimization I can do at some point. That'll get rid of the multiplication. For the 3, I'm getting a feeling that I need to do +1 before Yeah, I think I need to do round up. So yeah, we're supposed to get 4 on this first one, so that's correct. And we're supposed to get 8 on the second example. Let's see if that is indeed the case. Was it example 10b? Yep, farthest 8. That's right. So let's run it on the input. And fingers crossed if this is gonna work. Okay, so here we go. This is gonna take a couple of minutes. Yeah, super curious what the next part is gonna do with these extra pipe pieces. Do they form like a loops of their own? No, they are like whichever way in weird fashion. Okay. 6846. Well, that's a nice number. And I think that might make sense given that start X and Y and the width is 141. So yeah, so 6846. Let's give that a go. Command A. Answer 6846. 6846. Yep. All right. First try, first star. Nice stuff. Okay. So now what is gonna happen? What is gonna happen for the second part? So up. So let me print this one out. Go to the second display here. Congrats. Well, thank you. Yeah, that was a that was a fun puzzle to do. Yeah. How does this second part gonna go? So print. Okay, that was all of that stuff. Let's get this out. Huh? Oh no. Cool. Okay. That's a lot of stuff as well. 3 pages. 3 pages. So now I think we're gonna do something with those pipe pieces. You quickly reach the farthest point of the loop, but the animal never emerges. Okay. Maybe its nest is within the area enclosed by the loop. Okay. To determine whether it's even worth taking the time to search for such a nest, you should calculate how many tiles are contained within the loop. Well, we could do that. For example, okay. Start. There is a, yeah. The above loop encloses merely 4 tiles. The 2 pairs of periods marked in the southwest and southeast. So those would be, I think, these, right? The middle period tiles marked O. Yeah, those ones are not in the loop. Yeah, because these ones walk out from here. In fact, there doesn't even need to be a full tile path to the outside for tiles to count outside the loop. Squeezing between pipes is also allowed. Here, I is still within the loop. And O is still outside the loop. Oh, now this is getting a little bit tricky. Because because the printing doesn't line up for me. So what is happening here? In both of the above examples, 4 tiles are enclosed by the loop. Doesn't it even be a full path? What? Okay, now I'm struggling to read this. So this one goes here, which connects here, which connects here. Squeezing between pipes. I is still within the loop, and O is still outside the loop. Oh, I see. Now I understand. So yeah. Now I understand. Okay, so these O's here, they don't have a way like in here. They don't have a way to come through. So this one is pushed, but it's still. So basically, we consider it to be inside the loop. Yeah, just by winding. Yeah. Okay. That makes sense. In both of the above examples, 4 tiles are enclosed by the loop. Here's a larger example. Okay, yeah. Yeah, that's a larger example for sure. The above sketch has many random bits of ground, some of which are in the loop, and some of which are outside O. In this larger example, 8 tiles are enclosed by the loop. Any tile that isn't part of the main loop can count as being enclosed by the loop. Here's another example with many bits of junk pipe lying around that aren't connected to the main loop at all. Oh, this this is not that easy to read, but here are just the tiles that are enclosed by the loop marked with I. In this last example, 10 tiles are enclosed by the loop. Figure whether you have the time to search for the nest by calculating the area within the loop. How many tiles are enclosed by the loop? Wait, what the heck do we do with the junk pipes? We're not calculating the number of junk pipes enclosed. We're just calculating the number of tiles enclosed by the loop. Are those junk pipes there just like for visual trouble? Is that what it is? So that you cannot just... Yeah, because otherwise you could just do this on pen and paper. Easily. I mean, you can still do this by pen and paper, right? Oh, but the real inputs is so large that... Yeah. Then tiles are enclosed by the loop. Okay, so... Let's see. So here's an example. Actually, let me change it to this way. So here, okay, so this is cleaner to read. So there's four spaces contained within the loop, 4 tiles. In both of the above. So here's a larger example. Okay. Yeah, this doesn't quite come. Any tile that isn't part of the main loop can count as being enclosed by the loop. Here are just the tiles that are enclosed by the loop marked with I. Okay, so I'm gonna save this example. Save 9 2023 dot example 10 c.txt. So I need to be tracking the winding direction. How many tiles are enclosed by the loop? So okay. Okay, so what I'm gonna do is I'm gonna track the winding direction, and then I am going to do a flood fill. Yeah, that's gonna work. Okay. But the question is, do I have enough memory? Okay, so now I need to be mindful of memory. So let's double check. How many? How big is our map? Yeah. How big is our map? So should be less than, oh, my 20,000 bytes. That was actually a little bit lucky that it even worked on the first run. I didn't check this before, but yeah, 19740. Okay. So what I need is now my flood fill space. Or like scene. That's gonna be 20,000. Oops. 20,000 plus 7 divided by 8. And now I'm gonna do scene xy as scene. Actually, not a define. Let's do bool scene x y. The width it needs to be hoisted here. Let's do visited. So U16 index equals this thing. Let's put it here at xy. And then I do byte index equals index shifted right by 3. And then bit mask equals 1 shifted left by index mask 7. So I'm gonna save this over to nb.cpp. And then return scene byte index masked by bit mask. And then void mark with the same thing. but instead let's add this bit mask. Ooh, something is not quite right here. Yeah, let's just put this in here. Cool, okay. Oh, Mark came with 2 A's. No, I crashed. So this happens only on bigger files. So what happened is that the disk drive is stuck spinning. And it's no longer saving. I have no idea what causes this bug. Darn. TCPP. Yeah, not quite sure what causes that issue. Okay, now I get to do this again. Okay, cool. Let's hope this works now. Please don't die saving. Okay, so now it worked. Yeah, that's that's a really tricky thing. Oh, and Mark had 2 A's. But yeah, now I need to track the winding direction. How do I do that? I am going to do Oh, but yeah, it can be implicit because I can go the loop whichever way I want. Oh, but that requires me to guess. Well, maybe I am in the mood for guessing. I'm just gonna guess. So I'm gonna assume my winding order for now. Let's do that. And that means that whenever we come to an XY, so okay, so immediate, okay, to start with, for our flat fill, we mark where we are. And then whenever, and the first step we take, we also mark. And then whenever we make a step, we mark. Oh, mark, that was lowercase. So I'm marking this. So the pipe is now all marked. But what I need to do is now mark, according to the winding order, all the squares, or not mark, but NQ. So we have our Q, which, how large can this be? Oh, because now I'm not using it. It's optimizing this already. Okay, and then Q used. I'll just do Q size. Yeah, Q size. So I want to do this before. Let me do it here. Can I figure this out? So we're here at an XY coordinate with the direction we came from. XY coordinate with the direction that we came from. Or direction that we are headed, I mean. So I should be able to do just switch direction. And then do case. We're going up. So if I'm going up, I want to, if not seen, so I'm gonna do right winding order. Wait, what was my function? Visited, yeah. So if not visited, if we haven't visited, so the idea here is that I'm going to assume that while we're going, basically to our right hand side is going to be inside the pipe. I mean, it's going to be either to the left or to the right. So we should be fine either way. Oh, actually, write down. I don't need these. They can be like that. Oh, let's save. Please don't crash. Okay, cool. So if I haven't visited the cell to the right, I need to queue it up. And that was a queue. Queue size plus plus equals x plus 1y. Wait, what? Non-constant expression something. Yeah, that might be an improvement to maybe make the error message scroll. Equals dot x equals x plus 1 q size dot y equals y. Right. Okay, so how about we're going down? So then the reverse applies. X equals x minus 1, so we queue up. And then up, down, left. We're going left. So that means that our right hand is gonna be pointing upwards. Yeah. And then we're going to the right. Then our right hand is going to be pointing down. Okay. Let me reopen this. See if I got a issue with the compiler. Oh, and I ran out of memory. Okay, so yeah, this is getting to the tricky parts. My memory allocator should be pretty good at cleaning up fragmentation when I unload the memory, but I don't quite know if I have a issue there or some kind, but okay. Yeah, I have 1.3 kilobytes available. This is getting pretty tricky. And yeah, this could be a macro to share these few functions, but I can clean that up later. Yeah, that should be fine. I don't need these prints anymore. Oh, and this returns 0 also. Unnecessary now. Okay, let's see. So what I've now done is I've generated a queue of flood fill locations, and now I have to unwind that. This didn't occur. And in part B, well, I can just print that still. Doesn't matter. So yeah, okay, so now I need to unwind the flood fill queue. While queue size minus. Oh, actually, hold on, a big bug potential. So if inside the pipe is to my right, for example. No. No bug potential, because this should be seamless. Yeah. Okay, so now unwind the queue. If visited queue size X, queue size Y. Continue. So we skip already visited bits. Queue 16 inside num inside equals 0. Otherwise plus num inside. And now the flood fill. Actually, let's do this. U8x equals this part. And U8y equals. Oh. If visited x, y. Continue. Number inside, yeah. And now need to put all the neighbors. If x is 0, we got out of. So we guessed our winding order incorrectly. Likewise, y equals 0. Or x equals width. Or y equals height. But I didn't calculate the height, so I'm not gonna check for that. Okay, so now QSZ. So if not visited x plus 1y, x equals x plus y, QSD plus plus dot y equals y. Q is such a long word. I don't like long words here. Undeclared Q. Yeah, I should probably make this a macro or something that would work better, but but now I'm basically done almost. So if not visited x minus 1y, equals x minus y, and then same for y plus 1 and then y minus 1. Oh, where is that coming from? y minus 1. Okay. Yeah. And expected. Okay, now this is not synchronizing properly. Okay, so now I know actually what's gonna happen. So I'm gonna close. I just saved, I just did some edits. And let me check how much memory I have. Okay, so I have 5 kilobytes, so everything should be free. But now I bet if I open this, it's gonna run out of memory Yeah, yeah. So there is some kind of fragmentation issue in my memory allocator. So it should have the memory, but it gets fragmented. That's kind of unexpected because I did implement the defragmenter in the freeing algorithm, but maybe there is a bug, so it doesn't properly defragment the heap after everything's free. Because I don't think I should have any persisting allocations. And now it's gonna work. And I had 500 bytes free last time. Now I have 950, so that's much more. Okay. Printf. Okay, so let's take the C example. EX10C. Yeah, a lot of stuff that could go wrong here. Do I need to add debug prints? Maybe I'll add some debug prints in the flood field. Here. Okay, let's see what happens. Or maybe I should have put that after the continue. Zero cells inside. Farthest 80. That doesn't seem right. Wait, what? How is that possible? This was the example. It's getting 80. Or maybe it is possible. The map is in the example is 20 by 10. 200, so it's about half. Well, yeah, it is probably possible. But let's put this here. Nothing is inside according to this. Zero cells inside, so my flood fill isn't finding anything. Maybe my winding order direction guess was incorrect. Maybe that's what's happening. Can I easily change the winding order? I can, because I can change -1, -1. Oh, but I should have gotten that. Well, let's test that out. So, or actually, no. What I'm gonna do, instead of changing all of these, I can change all of these. Yeah. Now I should get an oops if. I'm not getting an oops, but it's running infinitely. What did it print? That was quite unexpected. So, why wouldn't this work? Why wouldn't this work? I just realized something. I only need to care about the winding order if I'm traversing a direct byte piece, but it doesn't matter. Does it matter? So basically I would need to do this winding thing only if I'm in one of these cases, because because when you're in a corner you're not going to be neighboring a cell that is inside. Yeah, it would be a nice optimization. So let me do that. If C equals down or C equals minus. But that's not gonna that's not gonna change my bug here. Down, up, right, left. Let me see the original example, the 10A, because that should have, wait, where is it? Here, so the very original example should have one cell right in the middle. So if I run on that one, example 10, I should get here I should get 1. 2 0. Two 0. That is completely incorrect. So I should be getting I am only enqueuing 2 0 here. I'm gonna get rid of this. Enqueued. What on earth? Wait, this. Yeah, no. Oh, wait. Did I mess up? I'm actually starting to be a little bit hazy on this comma operator and plus plus. Actually, I should verify that, but I thought it was evaluated from left to right, but so this is like, this break doesn't belong here, so this one goes like this. But so I'm getting the impression that either this visited function is incorrectly written. I mean, I am in queuing 4 times, so that does reflect to the for four directions. Let's print here. At 2-1 we NQ 2-0. At 2-1 when we have character equals C, direction equals D. Character equals C and direction equals D. What were my characters? Up, down, left, right. Up, down, left, right. What the heck? Okay, so character is minus, direction is 45. Okay, so let's double check this stuff. I thought that in printf everything gets promoted to integer. Yeah, it does. Direction equals 45. Direction equals 45. When direction should be 1 of 0, 1, 2, 3. Now I have something going really odd. Direction equal 45. This is really weird. So int direction, int up, int down, int left, int right. What? Int left, int right. Okay, so now something is really getting corrupt. Direction is 3 in beginning. And the enums are right, 0 to 3. Then we are at 2, 1. Oh, D. Der. Crap. What was D? Oh, D's. Oh my god. Oh my god. Like. Okay. Yeah, easy to do these kind of mistakes. Okay, so I was printing the wrong character. Yeah. Okay. At 2, 1, direction is 3. So direction is right. Direction is right. In this case, I should NQ. Yeah, I should NQ this way. Oh, this turned out to be quite the debug spree. NQ. Okay, so no, that's right. So the very first one at 2, 1, direction right. We're going to the right, and then we NQ 2, 2, which is the middle character. Then we have at 3, 1. We don't do anything, yeah. At 3, 2, direction is 1, up, down. NQ 0, 0. That is not right at all. We should be NQing again 2, 2. So we had direction down. We have this case. Oh, am I beating the comma operator here? Did I get too smart for my own good? But that shouldn't be the case. This should work. This should be just valid syntax. I mean, not the one that I use that often, but... No, still NQing 0, 0, so that was not the case. So we had 3, 2, and we're direction 1 NQing 0, 0. Q size is like this also match up. Yeah. So something is really wrong, because there's no way this should be in queuing. We're assigning x minus 1. We're assigning 2 and 2. And then we're printing these values that we just assigned, and they come out as 0. Yikes. Let me save this. Okay, I did a change, so let's reset. I'm gonna reload this. So usually when I get this kind of situation, that means that I have to break out the disassembler and start reducing this scenario. But now what I just want to go try. So I don't have a feature in here that would allow me to do different optimization flags. So basically what I tried was I changed my server to use a different optimization flag directly in there. So let me run with that. What just happened? See, now we got the right value. No, we didn't. Actually, sorry. No. But now I get hold. And actually, hold. Yeah, in this case, hold gets me to this sprite monitor, so that's why it's going here. Okay, so I need to... Okay, so I think I've now been online for 2 hours and I really need to go get some lunch. So I feel like my program here should be correct, or modulo may be a bug, but the logic or the algorithm should be correct. The idea of doing a flood fill on the winding direction that correlates to the being inside the pipe. I think that should be the thing to get to the answer, but I cannot figure out now this issue why I'm getting this zero here. So let me run once more. Thank you, 0000. Yeah, this is now escaping me. All of those should be successfully in queuing 2-2. And the weird part actually here is that even though I do enqueue, then why don't I fill that properly? Oh, and actually I should mark here. That's the real bug. I should mark here. Yeah. Yeah, curious why it... Actually, no, I don't quite understand why did it go into the action replay monitor, because no, I do have the hold here. I have this check, so yeah, because x is 0 or y is 0 or x is weird. So this took it to the monitor. Or let's do here, or y is greater than 5. Oh yeah, that's why it returns. Oh, we still go back. That's interesting. Okay. Anyways, I'll have to debug this on the PC and break out the disassembler and start poking why those assignments don't go to the right values. I'm enqueuing incorrect node to be flat filled, and then that crashes something. So either I did a really silly mistake that I cannot just see on the C64 monitor, or there's something now a little bit iffy going on with the compilation, but we'll see. So I think I should be pretty close, and if I do get it working, I do want to benchmark how long it's gonna take for the C64 to do it. But I think this should be solvable on the C64 because the first part didn't take that long, and this flood fill isn't gonna be that taxing either, so we should be all good. But anyways, take care, internet. I'll see you then in the next one. Bye. Hello, internet. Now I have had lunch and I am back. Take a second look and yeah, I was reading through the code while I was having lunch and I did spot some issues. So now I'm going to see if those issues will fix the problem. Well, first off, when I was refactoring this code, I broke it. Because here, only if I have visited, or if I have not yet visited a node, I will add that to the queue. But then here I was still unconditionally incrementing this this queue size. So that was why these zeros appearing, and I was unconditionally printing this as well, independent if this was it. And you were probably screaming if you were watching this, noticing that I was just so slow on thinking about this. So let's fix this up. first off, I'm gonna remove this one. And then, actually, I'm just gonna remove this whole print. So the original code was just fine, like there was nothing wrong with it. Let's put the original code back. Plus, plus. So this was the original form. Plus, plus, and... yeah, nothing wrong here. But I think the main issue I had with this code was this calculation, this at calculation here. See, the way I went and defined this at macro was that it would return the character at this position. It wasn't calculating the linear coordinate. So that was so dumb of me for U16 y times width plus x. U16 y times width plus x. Like, oh my god, that was so sloppy. And then I actually have the classic issue here that I'm missing parents, but I don't think this this situation happened. So I don't need to care about that. Yeah, so let's see. So we have the example 10, the very original example. So what happens? What do I have here? Okay, so we are now printing the number of cells inside. So let's now double check what this gives. We get one cell inside and we get 2, 2, 2, 2. Yeah, just like we should. Okay, that's perfect. Now, actually, can I easily optimize the... Well, actually, no, I'm not gonna optimize anything. Yeah. But instead, I want to run on the 10C example that was given in this example. On this 10C example, oh, looks like my, oops, one cell inside. So this now seems like this winding order problem. So let's see. Okay, now I got this. So now this search went outside the whole map. So I think my winding order here is wrong. So let's flip the winding order. And they should be printing what was the value? Oh, it's still getting one cell inside. It should be getting 10 tiles are enclosed by this loop. Interesting. So seems like I have another problem here. That's very interesting. So let's see. Oh, do I need to? Well, actually width was 16-bit already, so this widening should happen by default, so shouldn't be an issue. Well, technically, I think this would have to be a char to be right. Oh. Oh. I had these here. Okay, so that's one issue. I took the curly braces away to make those a single expression. Okay, so what do I get now? Still get an oops. Let's try the other winding order. Up, down, left, right. Zero cells inside. So I don't go outside, but so when we execute this, we get a bunch of cells that we are scanning. But none of those are inside, apparently. Is that right? Yeah, they're all visited. I'm queuing a bunch of already visited nodes, apparently. Let me see what some of those are. So what is 3, 1? 0, 1, 2, 1. That is quite interesting. So 3, 1, 0, 1, 2, 3 is it's right. So let's try printing here. Left. Like this, and then oh, what did I do? Okay. And then right. What happens now? I didn't get any of those. 3 and a 1. 0, 1, 2, 3 and a 1. Very, very peculiar. Okay, so I still have something to figure out. Print all of these. So I'm gonna now up, down, left, right, and then here before I start going through the queue, I'm gonna pause. So according to this, I am going up on 1, 0. Yeah, that's correct. I'm going left on 3, 1. No, left on 3, 3, 3, 2. Okay, let's check the smaller example still. Yeah, this is all good. No, wait, what else? I'm printing something weird. Oh, crap. These debug prints are all wrong. -1. Y x -1 x y +1. Yeah. Okay, now let's give this a go. Okay, so yeah, that's just exactly how this should go. Let's check the the B example. What was the B case? Yeah. One cell inside. So that one also is completely correct. So what's wrong with the C example? Some of these prints don't make any sense because this is kind of showing that I would be going right on 16-1. 0, 1, 2, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, 1. So right 16, 1. So it's queuing this node. And write 17, 1. 6, 7, 8, 10, 11, 12, 13, 14, 15. So like it's queuing like these nodes. According to this. That's weird. What do we get if we run on the actual input? Oh, I got the disk error trying to run the actual input. Oh, because I typed in the wrong file name, that's of course. So the actual input. So this is still all reading in the input file. Oh, this print, actually I should have commented this out. This is just noise right now. Oh, and there's gonna be a lot of printing. Well, I guess while I waited this long, might as well be patient. Okay, so that finished and it gives the same result for that one as before. And then I get a lot of unvisited nodes. Okay, this is giving me an idea that I would be outside the map, given that it's scanning like that. Yeah, most likely. Oh, yeah. Okay, so so this was now not the right winding order. So let's switch this around, up, down, right, left. And get rid of these prints. Let me see. Yeah. Yeah, it's those multiplications that's basically killing the C64 because the Commodore doesn't have a multiplication instruction. Oh, 288 cells inside. Interesting, okay. Well, that is something that I could try to submit. 288. Yeah, let's give that a go. Let's save this. Okay. $288. Not the answer. Your answer is too low. Too low. So what should this example input give? It should give 8. Why is that? There's 1, 2, 3, 4, 5, 6, 8, 9, 10. Eyes are inside, so there's an inside one. Now I think I know what I'm gonna do. Let's visualize this. Or can I do that? Maybe I can. Let's see. So actually, instead of printing this stuff, can I do... Let's see, volatile Q8 star screen equals 0. If I remember correctly, no, I've relocated this screen, but that's only for the editor, so this should be in the default location, which is 400. So I think I should be able to do screen y times 40 plus x. Oh, x equals c. Oh, source screen. And then here I want to run the example 10c. Yeah. What happens with this one? Wait, no, it didn't print any. No, it might be relocated. So let's try CZ0. Okay, now I visualize farthest. Oops. Okay. So I need to stop with this printing, and then this sketch should go, and then this printing. Oh, I should do a screen. 999 equals, let's say, 4, whatever. Okay, so now I get a character at the bottom right when the execution is finished. I can do this. And I want to get rid of that. So let me just do this. But I should convert these to screen code because they're now in Petsky, and the character set for the screen is different, and I don't have a conversion function, which is a little bit annoying. Also, some of these prints are now maybe a little bit off. Actually, this is a little bit weird compared to this map. Like, some of these parts seem to match, but some of them then are completely different. Which is super weird. Yeah, there should be. There should be fine. Do I have the screen code somewhere? Or actually, let me just put in some character. Do I have the screen code somewhere? Screen code 315. Okay, well, that wasn't too helpful. Oh, what's the screen code? The character code -32. Or minus, not 32, but minus what? Minus 64. Oh, that's weird. No, it's not quite that. Okay, let me quickly look up a function for. I have somewhere a function for this. Okay, so. Or actually, what I could do is get that function in the. Yeah, I could just add it to my standard library. Let's see if that works. To screen code C. No? No, this should work. Static declaration. Let's get the screen code. Let's see the screen code. Oh, now I think I know what's happening. Yeah, I might have this somewhere else, so. Okay, now it works perfect. Yeah, I was using this already in the standard library. Okay, so now I get a visual map. And but what the heck? This doesn't even match the map that I have. Oh, that's because there are two examples. There's a... Here's a larger... Oh, there are two different examples. Okay, so I was looking at a different example. So there should be 10 tiles enclosed by loops in here, in this one. So let's see. Okay, now this one matches. Yeah. I was looking, so so there were two different files. So there was this one and then this one above that are two different. I thought these were the same examples. But this one just had this junk added, but they're not. So this visualization looks fine. Okay. So let's visualize more. So I want to visualize I want to visualize which ones we're visiting. So where's my screen? Okay, now I need to know where's my colors list. Just a second. My color RAM is at D800. So I get my color RAM at D800. And here I can put in color y times 40 plus x is equal to 3, for example. Let me put in macular, let's put in sketch here, and here I want to do color y times 40 plus x equals 4. Actually, I can go here, so I'll do this. Okay. Oh, because I got the oops. I should still have gotten... What is 0 color? Screen y times 40 plus x. Let's invert this. So if I flip the highest bit, that's gonna invert the screen. So that one. That's the first tile that this one is searching. And that's outside the screen. Why is that the first? But yeah, so that goes out the screen. Okay, so let's try the other winding order here. Up, 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 down, left, right. Oh, that looks good. I think. Wait, what? Wait, what? Oh! Oh, no, this check is wrong. Yeah. This check is wrong. If x greater than 0 and then if y greater than 0. And here, if x smaller than width. And here, what is overhaul? I guess I need to calculate the height. So here I can put in if y smaller than height. And now the height. Height equals, oh, not here, here. Height equals length divided by width. Oh, but I'm still getting... an oops. Oh no, wait. Oh no, I was just... crap. So I missed this one. Okay. Zero cells inside. Okay, so now I should be able to figure out so which ones are the inside cells. Outside, outside, outside. Inside, so I should have a cell inside on the fourth row. On the fourth row. next to the I and J. I and L. Wait, am I now? No, I'm again looking at the wrong. Oh crap. Okay. So fourth row. So 10 tiles. 10 tiles should be marked by this one. JLJI. Okay, so that one is not seen. Oh, but wait a moment. No, it's not just the winding. Okay, so I have misunderstood this problem. So it's not just the winding order. Let's reread the description. Yeah, so I have misunderstood this. So, so what is happening here is on the fourth row, there's this JLJ. I think maybe I can show it with this one. Oh, does it show? So here I have this JLJ thing. That is this one. And the puzzle input says that this one should be part of the area enclosed. Oh no, wait, it is by the winding order, but oh, I'm coming from here. Oh, maybe my special check for this special check doesn't hold. Yeah, that might be the issue. Let's see what happens without this. Ten cells inside. 10 cells, that's the right answer. Okay, so that was my wrong assumption here. That's perfect. Okay, so now let me save this. I need to tear down this visualization because it's not gonna work for the big input. And then I can run on the big input. Yeah, so you can kind of fully enclose a cell inside the pipe by corner pieces. So that was my mistake. Okay, so let's see. Let's get rid of this visualization. This one, screen. Color and screen, okay. Perfect, and then this one and this one. And these get characters I also want to get rid of, yeah. Nice, okay. Let's print that one as well. And then see what the real input says. Hopefully I didn't forget any debug prints or no, any other debug code in there. Cool, alright. So I put in that straight piece rule because I wanted to reduce the number of nodes that would go into this flood fill queue. And now I'm basically, I don't have any checks in there if the flood fill queue becomes too big. So yeah, I could have made actually just use the vector type that I have written for that one. Okay, got the farthest. Oh no. Oh no, that's a crash. Okay. Maybe I did overflow the vector type. Maybe that's the problem. A lot of stuff going on in today's puzzle. Pretty deep in the... Oh, and I cannot even... How does that happen? I can't load my input file anymore. Okay, so I guess that's gonna bring an end to to today's song. I cannot run my my input file, so that can happen as well. That's pretty interesting. How could I keep that in memory if I cannot open it anymore? Okay. But anyways, now I think I'm pretty close. The visualization looked good. So what I'm now going to do is I'm going to take that code from the disk, take it to the PC, then clean it up there, and then run it there, double check it works. And I'll put in the blog like the final running times if I get the right answer and how long it's gonna take for the C6. So I'm not gonna come back today anymore to do any more debugging on this. So you can read from the blog the end result of what happened. And yeah, that's gonna be everything for today. So quite the heavy debug troubleshooting day. I mean, first part went pretty well without a hitch, but the second part kind of got down to all kinds of debugging. So anyways, take care, internet. I will see you tomorrow. All right, bye.